What extension of the observable universe exists? Can technology push us past the limits of the observable universe? Does our universe have an edge? It's one of cosmology's trickiest issues. Would you ever reach a point where you are unable to go any further if you kept traveling across space in a hypothetical faster-than-light spacecraft, which lies past the universe's edge if there is one? Everything's really difficult to imagine. Then yet it can be quality challenging to comprehend an infinite universe. Let's begin with a related but simpler idea. Our universe appears to have an edge, which is known as the cosmic horizon, the beginning of it all. Our cosmos began to exist some 13.75 billion years ago. Primordial light began to shoot throughout the cosmos and spread throughout the early universe very shortly after that. The universe itself was expanding at this point. After the first initial burst, the universe's inflation slowed, but since then, under the influence of dark energy, the pace of expansion has been continuously growing. This indicates that the maximum distance to which we can now view the universe is 13.8 billion years away. This so-called co-moving distance, which has increased due to the expansion of space, is roughly 45 billion light-years away. Anything beyond this distance is invisible to us because there hasn't been enough time since the creation of the universe for light from these far-off places to reach our telescopes. However, this cosmological horizon is not any actual physical barrier, much like the familiar horizon seen by sailors on the ocean. Space extends beyond our observable universe, much like the ocean does beyond a sailor's horizon. There is no reason why galaxies couldn't exist at these astronomically far distances. They are simply hidden from our view, regardless of how great our telescopes are. We're still not sure if the universe is infinite or finite, despite the fact that we know it extends past 45 billion light-years. There is no edge to the universe, that much is certain. Edges of the cosmos have no physical boundaries, such as a wall, border, or fence. However, this does not necessarily imply that the universe is limitless. If three-dimensional empty space is geometrically curved in a specific way, which is definitely a possibility according to Albert Einstein's theory of general relativity, then we may theoretically exist in a finite universe. If the universe has positive curvature, it would resemble a beach ball's curved surface, but instead of being a 2D surface, it would be 3D space. There is no edge or boundary to the surface itself despite the fact that it is finite. If you were to live in this flattened version of the universe, you wouldn't require an endless supply of paint to cover it. In 1960s, Albert Einstein applied his groundbreaking theory of gravity to the universe, the largest source of attracting mass he was aware of at the time, replacing Newton's theory, which had been developed in Berlin during the height of World War I. The universe could not be stationary and had to be in motion, either expanding or contracting, as demonstrated by Einstein's theory, although it was others who noticed this, not Einstein. In reality, the American astronomer Edwin Hubble discovered in 1929 that galaxies are fleeing from one another in the wake of a colossal explosion called the Big Bang. The earliest photons that we can observe, according to cosmologists, have traveled 45–47 billion light-years since the Big Bang. With a few light-years of error, this indicates that the size of our observable universe is roughly 93 billion light-years. All of the quarks, quasars, stars, planets, nebula, black holes, and everything else that we might potentially view are contained within this 93 or so billion light-years. The observable universe only contains the light that has had enough time to reach us. If the universe is just 13.8 billion years old, how can it be 93 billion light-years across? The distance hasn't been covered by light The answer to the question of whether we could ever travel to the boundary of the observable universe and what lies beyond is ultimately found in knowing this aspect of physics. To explain, special relativity states that things cannot move faster than the speed of light when they are near one another, but that this restriction does not apply to objects that are very far off from one another when the distance between them is expanding. The distance between atoms is expanding, which causes them to fly away from each other at incredible rates. Not that other objects are moving faster than the speed of light. This ultimately means that we could only reach the edge of the observable universe if we devise a means of transportation that enables us to first travel faster than the speed of light, which most physicists believe to be impossible, or second, transcend space-time by using wormholes or warp drive, which most physicists also believe to be impossible. This initial concept is one of the simplest to understand despite its weirdness. According to astronomers, the universe beyond what can be seen may be a limitless expanse of matter that is distributed nearly identically to that of the observable universe. After all, it is illogical for one region of the universe to differ from what we observe in our surroundings. And who can imagine a cosmos with an end, with a big brick wall waiting at its edge? That implies that if this is accurate and we follow it to its logical conclusion, there is someone else out there who is exactly like you in every way imaginable, as well as a version of yourself who is only marginally different from you in every way imaginable. One is an inch shorter, one was killed by a bus 5 years ago, one is missing a finger, etc. The only difference between you and this other your version, is that they just picked their nose while you didn't, or did you? And this other you may even be reading this article right now. This idea appears incomprehensible, but it's also difficult to imagine infinity. A world of universes is an additional possibility. Some theorize that the entire cosmos might be contained in a teeny bubble in the middle of an enormous number of other bubbles. Physicists refer to this as a multiverse. The theory, which is intriguing, claims that these parallel universes might interact with one another. Gravity can move between them, and when it does, a Big Bang similar to the one that produced our universe may take place. Others will undoubtedly assert that because the Big Bang occurred 13.82 billion years ago, the universe has an advantage. Therefore, the only galaxies that are visible for us are those whose light has traveled to us in less time than 13.82 billion years, about 2 trillion. These galaxies are found in the observable universe, a region of space centered on the Earth. Similar to the horizon at sea, the observable universe is surrounded by a cosmic horizon. We are aware that there are more galaxies, perhaps an endless number beyond the cosmic horizon, just as we are aware that there is more ocean beyond the horizon.